My wife and I live in a keyless world. It's not a world without locks, it's just a world without keys. For the last 40 years, I've designed, built, and installed controllers for all of the cars that we've purchased. This is the latest one. You can see that the car is now unlocked, and if I push the switch again, the trunk will open. So here's the inside of the trunk, and in the corner you can see the controller box. This is the key fob with the battery cover and battery removed. My first experiment was to see if just powering the key fob would unlock the car and allow it to drive, and see how long it takes to do this. For 11 cents, a dime and a penny, I made a dummy 2032 battery. I could have soldered to the key fob contacts, but I was hoping not to modify it. In my hacking, I usually try to make modifications that can be undone with no evidence left. The experiment worked. I could switch on the battery and the car would unlock, and I could drive it without any issues. It worked both inside and outside the car. A second experiment was to disconnect the battery once the car was running. This would simulate a situation where the battery died or your kid threw the key fob out the window. As expected, the car continued working. And as expected, once turned off and exited, it locked and stayed that way. So now it was time to design and build a controller. The key feature would be to make use of the existing rear hatch switch above the license plate to power on the key fob for enough time to get in the car and start it going. The key fob would get powered for 5 minutes after a predetermined sequence of rear hatch switch pushes with long and short pauses in between, sort of like Morse code. Additionally, since I had a whole 256 bytes of instruction code available in the 8-pin microprocessor, I added a feature that could connect a secondary 12-volt backup battery to the main 12-volt system. By holding the latch switch for 30 seconds, the secondary battery would connect through protection circuits to the main system. Holding the latch switch for 5 seconds would disconnect the backup battery. Since the car is only a few months old, this is a future feature. The module on the right is a design shortcut that I was able to take. It drops the 12 volt from the car, or battery backup, to 5 volts for the processor and 3 volts for the key fob. Here's a portion of the code for the Pickaxe 8M that I used. It was a spare that I had from a previous project. Since I had virtually no documentation from the car, I ended up taking a brute force approach to tapping into the rear hatch switch. It was not easy, and closing it back up was no fun. Here's the car back together with the power, ground, and trunk release wires poking out from under the carpet. And here's the wired circuit bench tested and ready to try out in the car. Things went well at first, but even though the controller board indicated that the key fob was being powered, the car wouldn't always unlock. I tried different positions for the key fob but couldn't find a reliable location. After a little research, I learned that there are 7 antennas scattered around the car that look for RF signals from the key fob, and apparently they all look for motion, like a driver approaching the car. This was an unpleasant discovery, but all was not lost. After finding out what it would cost to replace the key fob and the process involved, I decided to sacrifice the second one that came with the car, and hopefully not destroy it. My approach was to electrically double-click the top center button. That's the button that locks and unlocks the car, and as long as I had it open, I figured that I may as well solder in the switch 3-volt supply as well. Here's a circuit board with the key fob guts mounted in a box, ready to test in the car. The double-click key fob worked fine at unlocking the car, but locating the controller hidden away in the far corner of the trunk was problematic for enabling the drive mode. Apparently, Tesla doesn't accommodate backseat or rear trunk drivers, so an extension cable and a little Velcro on the box solved the location issue. It's kind of nice that the trunk lining works so well with the hook side of Velcro. Here's a circuit with the key fob control added. Note the use of an opto-isolator for the hatch release switch, just in case. I stuck all of the extra bits from the key fob into a bag in the controller case. If things don't work out, I should be able to restore it to its original state, more or less, and I won't wonder where I put all the case parts. Well, things don't always work out as planned. The 5-minute timeout worked fine with 3 exceptions. 1. The car wouldn't lock right away after a very short drive. Not really a big deal, but 2. The charging port would open, but wouldn't allow charging at a supercharger because there was no powered key fob in the car. And to make things worse, if a passenger was in the car didn't lock. That meant that pushing the trunk latch switch would actually open the trunk and make it impractical to do the unlock sequence. My wife was not happy. And 3. After charging, the charging connector couldn't be removed because, after 5 minutes, there was no powered key fob in the car. So here's the solution, or so I thought. By tapping into the brake light, I added code and circuitry that keeps the key fob powered for 25 seconds every time the brake light comes on. This also lets me shorten the 5-minute unlock timer to 2 minutes. Problem solved? Really close, but not quite there. The problem is that every time the car shuts off, Tesla makes the brake lights flash to let you know that the car is locked. Well, this flash causes my controller to power up the key fob for another 25 seconds and re-enables the car. This cycle repeats every 25 seconds ad nauseum. Not good. So I added some code that requires the brake light to be on for more than 250 milliseconds. An easy fix, and it works. It's been several weeks now, and other than a flaky solder connection, the system has been flawless. I may want to adjust some of the timing, but I'm almost ready to leave the primary key fob at home. Almost. For the time being, this is what I carry around in my front pocket. Just in case. It's a primary key fob in a copper sleeve, in a Faraday shield, in an Altoids container. This keeps the car from sensing the backup key fob. So why did I do this? A couple of reasons. 1. My wife doesn't carry any keys or key fobs. 2. It's a good backup for a missing or defective key fob. And 3. It was a nice little project and a way to continue 40 years of keyless cars.